And then when you arrived in London, it would direct you to your how to get to your hotel. And we also had digital maps and GPS implemented.
Right.
Um, and this is 1998.
So basically, we're
Um,
living in the future by far because that's today, right? With Apple Wallet and
yeah,
all that stuff, right?
correct.
Welcome back to another episode of Nerding Out with Victor. Today, I'm joined by Marcus Taylor from Planet Computer, and welcome to the show, Marcus.
Hi, thank you.
We've been talking for a while, and I mean, I was introduced to you guys way sometime 2 years ago, I think it's by now, maybe
Yeah,
not
that's
more.
right.
Yeah,
Hmm.
from the fine folks over at Canonical, and we were they were impressed with what you guys were doing, and as I learned more about what you guys are doing, I've been more and more intrigued. So maybe we can start to introduce the viewers to who's Marcus, what do they know, and then we can move on to Planet Computer and all the nice, lovely nerdiness that you guys are working on.
Well, who am I? Well, I'm sitting here in Uppsala,
Mm.
Sweden, which is where I was born. And at an early age, my father, who worked for the UN, took us off to Singapore, and I ended up after that in Italy. And then I branched out on my own after graduating from high school, and went to the UK and started working, I started working. And then I realized that I didn't want to be an engineer. So I applied to Loughborough University to do ergonomics and computer science. And I was there for 4 years and was sponsored by STC, which was Standard Telephone and Cables. And I used to work there during the summers and winters in their relay factory and eventually also at STL labs, and had a great time. Was introduced to a lot of really good tech. Even worked on the ICL one per desk, which was a precursor to, if you like, modern day communications. And wrote a couple of books about together with my manager about how to design CRT displays or
Oh wow,
cathode ray tubes.
blast from the past. We don't miss
And
lugging those around.
we don't. Actually, we ITT had then started making the first LCD screens, so that was quite interesting. And then I got a job with IBM in leading at their research center there, and worked on natural language interfaces to databases.
Right.
The project was called Sylvia, and we used the RISC architecture and the AS400 and the OS and VM and all that good stuff. And I mean, it was incredibly laborious at the time because you needed so much power to just even turn a statement like "Tell me who all the blue-eyed employees are in the company," and
Right.
then turn that into an SQL statement.
Right.
But in many ways, that was a precursor to large language models
Oh
because we
yes.
had linguists and everything working with us, going through the grammar, and we were doing it Swedish and English and Italian, and yeah, it was really interesting and seeing how people reacted to having a natural language interface to data
Yeah.
rather than
When
having.
was this? Just timeline wise, so people on the like.
This is 1993, 95.
Oh wow,
Yeah.
that's some time ago.
And then to distract myself, I joined the Stockholm Players and we used to go to, was part of a number of theatre productions and things like that. So that was kind of fun and played rugby for Stockholm, blah, blah,
Oh,
blah. So it was good fun.
very
Um,
cool.
and then I moved to Hanover and worked on a project that was together with Dassault for their CATIA CAD/CAM program, and it was again to create not so much natural language interfaces, but to automatically create the bill of materials from a drawing and allocate all the part numbers and so on. And so we did
Ooh,
a
that's
lot.
very timely because we're kind of full circle on that now again.
Yeah, yeah. And so we used to do a lot of usability testing, and I designed a protocol for doing that, and actually won an award from IBM for my efforts there, which was kind of fun. And then they whisked me off to Rome to work at the lab there, where I was working on different communication protocols like TCP/IP and Token Ring and so on.
Ooh. I haven't heard that.
Um,
I haven't heard Token Ring in a while. That's
yeah. So yeah, I've got my grey hairs, and again we were working on different ideas for. So they were very keen on also um, making software based on usage.
Hmm.
If you had a huge installation of CAD stations and so on, then you would only be billed for the amount of usage and computing power that you used, which I
Ah.
suppose for IBM was really going back to its origins.
Well, that's
Uh,
mainframe thinking, right?
exactly, yeah. Well, it's kind of what cloud thinking is today as
Yeah,
well.
true, 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 true. Yeah.
So, so then they decided to shut the lab and because this is when IBM was going through all its kind of, should we say, navel gazing. What are we about? What should we be doing? MS-DOS is overtaking OS 2 and so on. I applied for a job in the UK and joined a company called Logica in Cambridge.
Hmm.
And that was really exciting because the team in Cambridge was basically very multidisciplinarian. So we had projects ongoing for air traffic control systems, natural language interfaces, speech synthesis, and also at the time, of course, 95, 98, which is when mobile phones were becoming to come onto the scene, and Netscape and web browsers and all that good stuff. And smart cards were also becoming very much part of the game. And so we basically did a Venn diagram and said, well, surely the sweet spot is internet, smart cards, and mobile phones.
Hmm.
And so we came up with this proposition called mobile commerce. And we went to Barclays and
Is this like a
Nortel.
this is like web days, I guess.
No, this is pre-WAP. This is
Okay.
pre-WAP. Yeah, this is pre-WAP. Um, and so basically, we had a project together with Cellnet, Nortel, and Barclays, whereby basically the phone became your wallet.
Right.
And we proved that we could do all the transactions securely, et cetera, using USSD.
Hmm.
And but the outcome was nobody could decide who owned the customer. Was it the bank customer? Was it the mobile
Right.
phone's customer? Or was it Nortel's customer?
Right.
Um, it kind of basically developed into nothing other than being a great technical proof of concept. And during that time, we also worked with Chris Bonington. We set him up with a satellite phone and a digital camera. And as he was ascending K2, he was stopping every now and then and sending pictures back and a little report on how the ascent was going. I think it was one of the first applications of combining mobile phones and satellite comms. And then we did another project with Her Majesty's Revenue and Customs using the Newton.
Hmm.
Um, and that was basically to replace all the paperwork.
Right.
Um, and so there was a really quite exciting time, and because of that, because of the work we'd been doing with mobile telephony and so on, they moved me to the Stockholm office again,
Right.
and I ended up basically becoming like the Ericsson account manager, and we ended up being creating a consortium together with AU Systems in Lund, Amadeus in Stockholm, SAS, and Ericsson for ticketless travel.
Right.
So we took one of their prototype phones, which was basically a PDA with a touchscreen, and implemented a smart card with it. And so you would go to your mobile phone, there was an app there, you would book your travel based on what your commitments were. And then it would download the ticket, you'd go to the gate, you'd scan the phone, that would let you through the gate. Um, and then when you arrived in London, it would direct you to your how to get to your hotel. And we also had digital maps and GPS implemented.
Right.
Um, and this is 1998.
So basically, we're
Um,
living in the future by far, because that's today, right? With Apple Wallet and all
yeah,
that stuff, right?
correct. Yeah. So, and there's a funny story actually. When we first got the app running, this was going to be like the keynote for a kickoff meeting for the Ericsson executive team
Right.
out on Sandham.
Yeah.
And so we were debugging and debugging. I was sitting in my Solna office. And for 2 days straight, they kept calling me, "Is it ready?" No, no, it's not ready yet. We've still got a few bugs to iron out. And then midnight, the night before the event, we finally got everything sorted out. And then I was like, how do I get from Solna to Sandham in 4 or 5 hours? So I just took a chance and drove down to Gamla Stan, and by happen chance there was a guy in a speedboat there, and I jumped on his boat and said, "Will you take me to Sandham?" And he said, "Yeah." And so I paid him, and we set off at 40 knots across across the water. And then we got to the pier in Sandham, and I reached out with this precious phone, and he grabbed it, and I was having visions of it go plop into the water. Fortunately, it didn't.
Oh wow.
Um,
Oh,
and
that's
then
really cool.
and then because of those events, myself and Yanko and a guy called Bengt Carlson. Bengt was Ericsson, a director in one of their mobile divisions. Yanko was at Imperial College, but had
Mm.
also started a company called Dynamical Systems Research. And myself, we sat down one day and said, "Well, it's the dot com era. Why don't we just, get a move on?" So we founded Digital Mobility and set up in London. Um, and we got things moving quite quickly, raised quite a bit of money, and we had an alliance with Guernsey Telecom because at the time in the UK, you couldn't roam and you couldn't send SMS, for example, between Vodafone and Cellnet. Um, but if you had a Guernsey Telecom SIM, you could.
Oh.
So there was a big advantage to that. So we put together a package, the digital mobility package, which was aimed at high net worth individuals, frequent travelers, and so on, which combined travel, banking, telecoms, and so on. So I, being in charge of partnerships and business development, then had to go out and form partnerships with the banks and the travel companies and so on. And they were all very receptive until we hit the usual snag: who owns the customer? Um, so nobody seemed to be willing to kind of divvy up the the transactions in
Right.
an equitable way. Everybody wanted more than was satisfactory.
Right.
Um, but we soldiered on, and we were beginning to get results. And then we were about to get an investment of $7 million from Lehman Brothers. And at the 11th hour and 59th minute and 59th second, they withdrew from the deal. And so we were left, what do we do now? And so we ended up having to basically sell off the assets of the company. We sold our communication and Java applet distribution system to Tencent in China, and then what was left we sold to Norway to Schibsted. And fortunately, I still had my shirt on my back, and and shortly after that, I joined the GSM Association as a technical director and was responsible for mobile phones. And that was really interesting, understanding the politics behind how all these operators
Mm.
work together. So I certainly had an inside track on that. And so one of the things I was responsible for in my division was Wi-Fi and Bluetooth technology.
Right.
So the operators were like, is Wi-Fi going to cannibalize our business, or can we find a way to collaborate with these new mushrooms of Wi-Fi activity that are popping up everywhere?
Right.
And so through 3GPP, we came up with a standard which enabled roaming between Wi-Fi and 3G at the time. And then the same thing with Bluetooth. The Bluetooth SIG was very keen to work with the operators to find application areas and so on, and with all the various implementations. And again, mobile operators were kind of wary again because of how it might affect their business, rather than seeing it as an enabler,
Right.
which we are benefiting from right now by
Yes.
having excellent voice communication.
Yes.
Um, and then I was asked to do a press release about Bluetooth technology and Bluetooth SIG, which I did, and then Vodafone got really upset, so I had to leave the GSM Association for some bizarre reason. I hadn't got all the right ticks in the boxes, but that was no big deal because I landed a great job with a Swiss company after that, called SICPA, based in Pries or near Geneva in Switzerland. And SICPA are the world's largest producers of pigments and inks that are used in banknotes.
Okay.
And they'd spun off a separate division called Product Security, where they use their know-how in pigments and fluorescent pigments to create a technology for preventing counterfeiting and smuggling.
Hmm.
And this is used actually even today by big brands like Gucci and all those fashion brands. But also, we had they'd just landed a project with the Malaysian government to prevent counterfeiting and grey imports of cigarette packets.
Hmm.
So I was made the general manager of the new division in Malaysia and went out there, recruited a team of about 40 guys and girls, and the system was based on what were they called now? Anyway, an inkjet printer
Hmm.
that we put in line on the packaging line of the cigarettes. So you've got these packets of cigarettes flying by hundreds per minute, and this inkjet printer had to print the dot exactly in the right spot on the cigarette packet before it was wrapped in cellophane.
So it's
Um,
a watermark essentially that's unique to each.
yeah,
Well.
so it was a multi-level security. So you had your geometric shape, then you had your fluorescent ink, and then you also had if you like, a micromolecule with a very specific 3D shape that SIGPA made. So this was all part of the ink that was used, and so the idea, so the basically it worked like this: the cigarette packets went out into the market. Then the customs officers had a special little gun which would illuminate this dot, and then if it pinged back the right frequency, that the reader would give a green light, and you would know that it was a locally produced
Ah.
cigarette packet. But if it was red, obviously it had been imported from without
Ah.
duty paid. And so but of course, like anything, eventually some people will figure out how to analyze the ink and come up with something similar. But this, if you like, secret molecule was always if you like, the forensic test, which would determine whether it was genuine or not. Um, and then, so we had 7 packaging factories in Malaysia scattered all over the country. JTI, Philip Morris, etc. And we had to distribute the ink. So the whole business model was based on we supplied the equipment, we gave it to them, a bit like a Tetra Pak business model.
Hmm.
And
Yeah.
then the consumption of ink would determine, so how many dots they printed per month would determine the revenue that SIGPA would generate from that.
Ah. Okay.
Yeah.
Interesting.
And then, so then I telemetrized, if you like, all the printers. So I put a little GSM modem in each one. So we would be then centrally recording all the dots. So we didn't have to go out and take all the numbers off the printers every week or month.
Yeah.
And that was a bit, and that also enabled us to determine or predict when the printers needed cleaning or maintenance. So that went quite well. And then during that time I got married and my wife was pregnant, and SIGPA were so impressed with what we'd achieved that they then landed a project in Brazil, and they wanted me to go to Brazil to do alcohol and beer bottles. But my wife put her foot down and said, "No way, Jose." So,
Uh,
so then I was back in the UK. I'd resigned from my work there. They'd given me a fair settlement, and I was then trying to think, what do I do now? And then I went to an alumni meeting for my old school in Rome, St. Stephen's, and I bumped into a guy who was about 10 years younger than me, Francesco Cesarini. And we got talking, and he said, "I've just been made redundant from Ericsson. I used to be part of the Erlang team, um, and I'm starting up a consultancy here." And I was like, "Well, why don't we join forces? I mean, I've got a lot of experience working as a management consultant, system integration projects, blah, blah, blah." So he said, "Yeah, let's do it." So we got an office in Spitalfields, and one of the first projects we did actually took me back to Malaysia because I'd got to know quite a bit of people and had a bit of a network in Kuala Lumpur. And one of the guys I knew, Shukri, he was responsible for something called MIHAS, which was Malaysia's attempt to become, if you like, the center of halal food
mhm.
in the Far East. And you said we really need to find a way to create traceability for halal chicken and halal food. So, based on, if you like, the work I'd done with mobile telephony and Ericsson and with SIGPA, I said, well, I don't see why we can't come up with a system which would enable us to put markings on the chickens and the chicken produce using, if you like, using something similar to what we've done in the past. So we put together a solution and we presented it to the Malaysian government and so on. But then, of course, as usual, lots of people want a bit of the pie. And so it became an impossible business opportunity to actually execute on.
Yeah.
But that was kind of fun. And then so the consultancy started growing. We started getting more. Erlang was the language that Ericsson used for their AXE systems
Mhm.
and their base stations, the GSM base stations. And why did they do that? Because Erlang is, if you like, a virtual machine that is super resilient, very scalable, and fault tolerant.
Yeah.
So, even if base station goes down, it will then reboot and restart. Uh, and because there was so many out in the field, AXE exchanges, base stations, despite the fact that could basically shut down the Erlang team to its bare skeleton crew, they still needed people to carry on development, coming up with bug fixes and so on. So we ended up supplying them
Yeah.
with consultants to do what they had originally invented. Um, and so we did a number of different projects, and then because of the features of Erlang, we got involved with WhatsApp. I don't know if you know, WhatsApp is based on Erlang.
Yeah. Yeah.
We got projects with what do you call them now? Vocalink. Vocalink is the um, exchange center for all the clearing banks in the UK. So when money is sent from one bank to another, it goes through the Vocalink. And so they had a great big IBM system to do this. And they asked us to reverse engineer this to run on Linux boxes using Erlang, which we did successfully. And then they sold that to the Bank of Singapore.
Hmm.
And that went well. Um, what other projects did we do? We did ticketing systems, gaming systems. Yeah, it is very versatile language, and then I was getting to the point where I thought maybe there's something else I want to do in life, and we'd been approached by a Danish company called Trifork, And Trifork is a Danish system integration company in
Hmm.
Copenhagen, but they're actually based in Zug in Switzerland. And they're listed on the stock exchange. So I met the owner of Trifork, and he said, "Well, would you be interested in selling your shares to Trifork, and so we can really help Erlang expand and so on?" And so, yeah, he made me a good offer, which I couldn't refuse. Um, and so I took that on and moved on from there. And then after that, I invested some money in a company called Silent Sensors, which I helped co-found, which was how to make tires smart using, if you like, the beginnings of edge computing. So this was because of the legislation requiring TPMS systems in cars and vehicles to monitor tire pressures, which are fundamental to basic car safety. And then I so we built up silent sensors over time. Originally, we were using, if you like, an RFID solution, which required quite hefty antennas and infrastructure,
Hmm.
gates and so on, which was a bit of a non-starter. So then we went back to the drawing board and said, well, we need to provide our own power source because but at this point, we'd managed to interest some major tire companies like Bridgestone and Continental. And so we were looking at energy harvesting. So we found a piezoelectric solution, and then we found a solution for solid state batteries. So we created, if you like, a plaster or a flexible bit of electronics. And we were based up in Sedgefield as part of the CPI, the Center for what was CPI? I can't remember what it stood for. But basically, they had all the equipment necessary for flexible electronics production.
Right.
So we started making prototypes. We also interested MRF in India, and the project went very well. But because of the, if you like, the conservative nature of tires, it was necessary for them then to run basically millions of miles with the prototype tires to evaluate and determine that they were safe.
Not not very startup friendly.
No, no, there's a sort of the chasm of doom and destruction became insurmountable in some respects in terms of being able to get to a point where the investors felt they were going to get a return on their investment in a reasonable time frame.
Yeah.
But silent sensors are still going. I kind of browned out. I had had enough of this, and so I sort of said bye bye. Still got shares in the company, and they're still going through the motions and perfecting it and perfecting it. And maybe in the next decade it will come to light. But in the course of this, I again made a number of very interesting contacts. One of them is Invisa, which is a smart shoe solution, which is basically an activity tracker in your shoe, again using piezoelectrics and solid state batteries for the power source. Um, and also because of the solid state battery requirement, I found a company in Poland called The Batteries that can manufacture both the battery and the energy harvester in scale. So that's currently what I'm working on. At the same time, I'm working with Planet Computers, making mobile phones like this one with a keyboard reminiscent of the Scion.
Yes.
Um, and if you give me 1 second, I will bring another little prop. Hang on, be
Yeah,
right
yeah.
back.
No worries.
So, um, this is what we call our XR. It's
Yes.
not powered up now, but basically, this is a color touchscreen, which you can program and customize to customers' requirements, or basically as a out of the box solution. And we also prototyped some RFID rings, which you could use for making transactions and so on. And
But before we dive into that, I want to take a step back and like early
mhm,
days Planet Computer? Like,
Mm,
you started with Gemini.
hmm
Maybe like take me back to the early days there, so people who are not familiar with your kind of product portfolio and your backstory of how you came to be. Really, like, what was the starting point, and kind of what did you set out to do in the first place?
Right. Well, basically, the whole Planet Computers proposition is based on, if you like, the ergonomics of a keyboard.
Hmm.
The keyboard is a very efficient way to communicate, and compared to touchscreens or voice communication.
Sure.
So, and the reason for this was also because of the, if you like, Imperial College. So the founder of Scion was a professor at Imperial College, and
Oh, I didn't know that. Oh,
yeah,
interesting.
yeah, South African. God, my name. I can see his face, but I can't remember his name. But it'll come to me. So Yanko and he became friends, and then when Scion basically shuttered because it was overtaken by events, and I mean, then we can go into the whole story about Symbian and so on and
Yeah.
so forth. But they weren't able to, if you like, keep pace with what happened with smartphones and integrate um,
Yeah.
5G, 3G, 2G into their phone, into their PDAs. But the basic mechanics and engineering of that PDA was still very valid if one wanted a pocketable PC, if you like.
Yes.
So Yanko did a deal, and Scion then gave him the rights to continue developing this. So, in order to get it to market, Planet Computers then did a crowdfunding
Hmm.
using Indiegogo, I think, if I remember rightly, and that was successful. And then so we had the Gemini, and then we had the Cosmo, and then we had
Hmm.
the Astra. I mean, yeah, and this. What Planet Computers never really achieved was, if you like, enough investment to do not just the design, development, and production, because as it turns out, mobile operators, they don't want to pay for the marketing. They want to do the distribution and so on, but they don't want to do the marketing. So if you want to sell 1 million phones, you need to have a marketing budget of probably £1 million to get yourself in front of everybody else. And then,
Yeah.
of course, we got the big players like Samsung and Apple and so on that so huge that they the effort, if you like, for a mobile operator then to sell these sort of niche phones is that the benefit to them financially is insignificant, really.
Yeah. Yeah.
So they don't really give you much time. Um,
Yeah.
so yes, you can sell them over the internet and so on, but you're constantly hitting that crystal ceiling, if you like glass ceiling, in order to get the volumes, because because the people that are producing it, they don't want to produce 10,000, they want to produce 100,000 or a
Yeah.
million a year. Um,
Yeah. The
so
the constant MOQ battle, right? And yeah.
correct, yeah. So we're still struggling on, if you like, and we're developing a new version with a better processor, 5G.
Hmm.
We're also looking at NTNs to make it satellite compatible, etc.
Right.
But that's still in if you like in
But talk to
the
me about, because the reason why I think it's interesting is it's kind of carries on Zion's kind of like initial vision, and obviously the form factor, obviously, which is, I guess, makes me nostalgic.
Mm,
But beyond that, there are some interesting use cases. I mean, we spoke about last time, well, with Yanko in London. Like, we spoke about some interesting use cases where these devices are being used, right? Like, they are not necessarily your consumer use case, because I think that
no,
that's obviously a very difficult market to get into, and
yeah.
not least from the pricing point of view with MOQ problems. But talk to me about like the use case guy. He mentions, I'm not sure how much what you can mention on the air, but he mentioned some real interesting use cases for like these applications or application of these phones in the wild that you've seen already today and your customers.
Mm. Well, I mean, I don't know. The most the typical use case is, if you like, business user that uses Excel and Word and so on, and doesn't want to lug a laptop around with him. He wants something he can stick on the inside pocket of his jacket. And from there, uh, you've also got examples of journalists use them quite extensively. There's some authors that use them quite extensively because it
Hmm.
enables them to, when something pops into their head, they can just whip it out and write a paragraph or a chapter on the train or wherever.
Hmm.
Um, so those are if you like, the typical use cases. I mean, I would say 95% of anybody that's bought a Planet smartphone is a male between, I guess, 40 to 60 years old,
Hmm.
because of the fact that they either had a BlackBerry or a Scion.
Hmm.
I mean, the other use cases are, if you like, for homeland security and so on,
Yeah.
because it's multi-SIM. We can customize it with different types of encryption. So we have customers in the Far East that use it for their police and so on. Um, but that's about, as wild as it gets.
No, but the reason why it is interesting, I think, is the multi-boot thing is an interesting,
Oh, you mean,
unique.
okay,
Yeah,
sorry. Yeah, yeah. You
yeah.
mean being able to switch between Android and
No, no,
Linux.
I
Yeah.
meant more like the use case for that, right? Because that in turn means that there's a very small set of users that would
Mm.
require and want such feature, right? And that's a very unique proposition, I think. I haven't seen anything out there that has similar functionalities in the same form factor, at least.
No, no. Yeah, I mean, that uniqueness is perhaps something that should be leveraged more. But on the other hand, when customers do require it, they want it in quantity. And
Mm,
at this point in time, we're just not able to do that.
yeah,
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 yeah.
yeah. Because that's, I mean, from a use case perspective, that opens new doors. In particular, I'm like, I just came back from DEF CON, and like, obviously, that's a space where I have a lot of security people there, and like being able to just whip out a tablet and boot up Kali or whatnot, right? And
Yeah.
some Linux distro and like do pen testing on the go on a small device is very
Mm,
covert, I guess, and
mm,
that's
mm.
a cool use case for these devices, right? Um,
Absolutely. Yeah, yeah.
um, but
Yeah, I
yeah,
mean, the
okay,
whole
so
cyber, yeah,
yeah,
I
go
mean,
ahead.
the whole cybersecurity thing is again something that we get pulled into, but um, and that's where the smartphones that we have are part of that solution, but also the network appliance that we've developed is also very relevant there in terms of creating a distributed network that is able to, if you like, distribute the computational requirements over a large area.
Hmm.
Um, and because it's got a lot of media interfaces, camera, audio, and so on, we can and so the current projects that we have at the moment, we have one in Singapore, which is called AI Connect, and that's about using artificial intelligence with CNC machines to improve productivity by monitoring parameters like sound, vibration, heat, power consumption of a CNC machine
Right.
to determine when the tool is going to wear out. Because if you can extend the life of that and reduce the number of tool changes, then your productivity goes up. But it also addresses the fact that there is a growing shortage of skilled machinists in the world. Blue collar work is not kind of like top of everybody's list when they're 18 and looking for a job.
Yeah.
Um, so the idea with the system is that it becomes, if you like, your assistant that tracks your skill level, provides you with feedback, tells you when to change the tool, tells you how to do the configuration and setup. Um, and so we have this appliance that I just showed you, and that's hooked up to the PLC of the CNC machine. So we're collecting all the
Okay.
data, and that's also shared with the rest of the factory. So if all the idea is that all the CNC machines in the factory are then connected, and then upper management can see what they need to order in terms of just-in-time flow of parts and consumables. But also the idea is, if you like, a lot of the application of AI and machine learning at the moment means that the time between something happening and something being done about it is actually the latency is quite long because it's the manager that makes the decision, not the
Yeah,
machinist. Whereas
right.
with our solution here, it's the machinist that makes the solution on the spot at the time.
So talk to me more about that. So you connect to, I mean, I guess your industrial control system of sorts, right? So maybe a CNC machine. This goes into the whole like Industry 4.0 kind of movement with preventive maintenance and all that stuff. But you have this device that connects one way or another to machinery, and then you
Hmm.
how what do you go from there? Do you have like a mesh network that you, because these are oftentimes not very connected environments, right?
Mm.
So because life cycle of these devices, machines tend to be meshed in tens or 20s of years rather than software where we have very
Mm.
quick churn, right? So these are probably
Correct.
machinery from quite old while that you plug into, right? So talk to me more about what you've seen there, the use cases there, because I think that's an interesting one.
Well, yeah, you raised two interesting topics there. One is the communication. So, in Singapore, certainly 5G is very prevalent, and private 5G networks are growing in popularity.
Mm.
So we can either use Wi-Fi or 5G. 5G offers a lot of features, if you like, that Wi-Fi doesn't in terms of security and allocating bandwidth and so on to different assets. Um, and the second thing you raised about is the, if you like, second-hand machinery can be
Yeah,
made smarter with this solution. So, and there's a lot of second-hand machinery that then has a second life.
yeah,
And then you've got new machines, of course, which also are a target, but less so, if you like, for where we are currently with the proposition. Um, so um, the the second-hand machinery, I mean, you could even apply this to machines from 20 years ago, because the
yeah,
precision is pretty much the same as
right,
machines that are on the market now. It's just that they've got more servos and more features and so on.
yeah,
But yeah, so I mean, there's a lot of trade going on, and so one of the markets we're exploring at the moment is the companies that refurbish these machines and then resell them. And by also offering these add-on services, you create, if you like, value-added services, which in terms of maintenance and support and so on, and making sure they have the right consumables at the right time.
yeah. I mean, what have you? I mean, that's the whole uh, industrial control system space I find fascinating because it's obviously there's just so much money tied to it, right? Because there's
Mm,
obviously entire industries depending on obviously that's the underpinning of these industries at large. But have you found like when you plug in these systems, I would imagine
mm,
a lot of it's proprietary systems, I'd imagine, and there's probably a lot of reverse engineering of protocols. I mean, diversity of protocols, CAN bus is probably involved, and so on and so forth. Like, what have you seen in terms of there to actually make this work for all the nerds out in the audience watching this? Like, what if you want to get into this stuff? Like, what have you found?
Well, I mean, basically what we do is we ingest all the manuals for the machine,
Yeah.
and then we plug it into the PLC system. And as you say quite rightly, we then integrate that so that we're taking the signals from the machines and feeding them into our box, along with all the data that we're collecting from our sensors. Um, And then, in order to calibrate the machine, we have a component that we make. And that component, if you like, stresses out the machine. We make it do stuff that is really on at the edge of the envelope of what it wants to do.
Hmm.
And that generates noise, vibration, heat, and power consumption. And then we can correlate that. So then we take the machine part off and we measure it. And then, we'll push it and push it and push it until we reach a failure point. And then we correlate the sound or the vibration or the heat signature to that point in time. So then, because this curve is sort of, usually it's not kind of linear, it kind of pops along and then suddenly it kind of
Yeah.
pops off the
Yeah.
scale. So we just need to focus in on that inflection point. And that's if you like where the AI comes into it, the LLM that is tuned to that specific use case. And that then enables us to, give feedback to the operator saying, refer to page blah, blah, blah on the operator manual to do this setting or to change this, etc., etc.
Right.
So in a nutshell, we're bringing together all the data because if you think back 20, 30 years ago, the machinist would be using his eyes and ears and touch to say the machine's running fine now, and then I don't know, he'd put his hand on the machine table and you'd feel a vibration. He'd say, "Oh, need to turn it down a notch now. Ah, that feels
Yeah.
better." You
Yeah.
know, a little bit like when you're tuning a car and you want it to just tick over smoothly. So you fiddle about with the carburetor until it's doing its thing.
Right. Right.
So, if you like, we're giving naive users the eyes and ears of an expert.
I mean, this is a long leap from where you started
Yeah.
with communication, right? But I mean, it's an interesting pivot, I would say, in terms of that. So that's cool. That's
Yeah, I
very cool.
mean, but I mean, I suppose at the heart of all this is DSP technology, digital signal processing, because that's what we're doing. We're processing, we're turning analog information into digital information, which we're then, in a way, turning into analog information for human consumption.
Right. That's fair enough. That's fair enough. Very cool. So that's where your is that where the current focus is mostly now, or is there a new is a new iteration of the Astro coming out, or how? What's the roadmap looking like
Mm,
for
I think at the
Logica?
moment the Astro is kind of on the shelf, if you like, and our focus is really on the network appliances because we see there it's an easier sell. We sell, if you like, to corporates or
Mm,
cloud users and so on. And we've got a lot of interest in Asia thanks to what we're doing in Singapore.
right.
And Japan, I mean, just looking back at the Astro and the range of phones that we did in the past, Japan was always one of our best markets because
Really?
because they like being able to type in kanji fast on the
Yeah.
keyboard. So that's just an aside, but interesting from an ergonomics point of view and usability
Mm,
point of view. Um, the other thing we're doing is we've also got a project in logistics using a radio technology from a Danish company called Neocortec.
okay.
And this is for tracking assets like the containers and pallets and packages.
Hmm.
And the use case is driven by Brexit. Because of
Right.
Brexit, actually, red tape has become even bigger for the UK market than it ever was before.
I can
So
imagine.
the basic concept that we're trialing at the moment is we have our NeoCortec mesh network tags in all the pallets, and when the pallets are loaded with the goods and products, they're all scanned and associated with this pallet. So when this pallet moves from, I don't know, Istanbul to London, um, when it's loaded, that bill of lading is sent to HMRC into the airline. The pallet is loaded into the plane. The other cool thing about NeoCortec is that if there's no gateway present, all the mobile nodes go silent. They're just in listening mode at this point.
Mm, okay.
Um, and they wake up. You can set the frequency at which they wake up, and that will determine the lifespan of the battery. But we've tuned it so the lifespan is about 7 years.
Oh wow. Okay.
And so the pallet then arrives in London. It's loaded off the plane, and there's a gateway at the airport, and all the little nodes wake up. And HMRC then gets notification that this has happened, and this initiates digitally all the transactions that are required in order for the goods to be imported into the UK. Payment of
Ah,
taxes, documentation if it's, I don't know, animals or whatever it might be. So that means that effectively, as soon as it's taken off the plane, the goods are cleared for distribution to wherever they're supposed to go in the UK.
that's very cool. That's very cool. So,
And so
because yeah.
so we're still using the distributed network concept here. So you've got the nodes, then you've got the gateways. The gateways are connected to an XR, and then that is, um, if like storing and aggregating the data and then redistributing it. So it also means it's resilient and fault tolerant. So if the 5G network goes down or whatever, we've still got all the data locally as soon as the
Mm.
network comes back up. Yeah.
Very
So this
cool.
can be applied then to sea freight, air freight, railways, um,
Hmm.
and so on.
Okay. Very cool. I mean, one thing I want to kind of look back into as we kind of wrapping up here is 5G. And you've been in the telco industry for a long time, and I at least I've been started to pay more and more attention to the telco world and kind of the commoditization, I guess, of the telco market in the sense of
Mm,
how things are moving to software. I've done episodes
yeah.
before on 5G and Magma and all these like open 5G networks and open source kind of eating its way into telco world. I'm curious about your vantage point there, how you see that and how you see that changing. I know there are plenty of big telcos that are doing pilots out there for this stuff. I'm not sure that's something you've been paying attention to.
I have to say I'm not as au fait as you are, perhaps, but I mean, as far as networks are concerned, the thing that we were seeing as a unique proposition was to implement NTN capability
Mm,
to enable the phones to work over the satellite networks.
mm,
Um, but I mean, because the Astro is basically an open platform, I see no kind of obstacles as to enabling it for other networks. But that said, it's always been problematic to make the Astro a global phone because of the so many flavors of 5G and all the different frequencies and so on.
yes.
Um,
Yes.
and that has also been a bit of a, if you like, a bugbear is how to keep abreast of all the various changes that are being made.
Yeah.
Um, so yeah, I mean, I suppose it's great in some ways that there's all these different flavors of communication, but it kind of also moves you away from the spirit of what 3GPP and GSM was all about from the beginning, was to create this universal, ubiquitous network to facilitate communication.
Yeah. Do you see a world where 5G or the whatever, well, 6G maybe, but the replacement of this will be as kind of a replacement for Wi-Fi, where like you will see much more of the private instances of these. So instead of you spinning up your own 5G route, instead of spinning up your own Wi-Fi router at home, you're on your own private 5G network. Because obviously you need telcos do not always have the best coverage wherever you live, right? So, uh, where do you see the world changing in terms of that?
Yeah, it's uh, I mean, why can't we have just one communication protocol? I mean, do we
Right.
need all these different communication protocols? I suppose if we look at it from the perspective of you've got your fiber network, then you've got the Wi-Fi that enables you to connect so you can go globally. If we go to 5G, 6G, I mean, even when we're talking 4G and 3G, there were many propositions for nanocells and microcells and
Yeah.
so on. Um, and they've not really made much headway. I mean, to some extent they have, but not what you would have expected.
Well, that's mostly
Um,
because of regulation more so than tech, I would say, right? Because it's very difficult to get permission for these deployments, and their cost is very expensive, right?
yeah,
If you want to buy a small cell, like your average consumer will not buy a small cell, right, and run it at home because they're way too expensive, and
and
inefficient.
complicated. Ah,
Yes.
and I think the same applies to small to medium companies. I mean, does the CTO or CEO have, or CTO or CIO have the experience to manage a network like this? Because there's so many parameters to set up and so on. Maybe this is again where AI comes into it. Maybe the whole process of setting things up can be offloaded onto a smart AI solution.
I mean, Amazon is playing this game already in the US, right, for private 5G. So
Mm.
there's a scenario where the clouds will be playing in this space, right? And the cloud instance becomes just another control plane for your local 5G, essentially, right?
Yeah, and then on the other hand, if we look at from the AI perspective, people or companies want to own their data, so they're
Mm,
becoming more and more reluctant to have that running in the cloud and want to have it on premises and maybe even air gapped for some
mm.
applications. Um, so you've got some interesting kind of problems. In fact, last night I was watching a remake of War of the Worlds, where the aliens basically are these data monsters that invade and infiltrate all the data centers and take over humanity by controlling all the data and take them back to the Stone Age. Fortunately, they just needed to put a DNA virus in, and that destroys the aliens. But um, yeah, you know, as soon as you start looking at this, you hit on privacy, just basic employment. What jobs are going to be out there in the future? Uh,
Mm.
where should our next generation be focusing their energies at school? There's a whole
That's, I guess
plethora.
that's the $1 million question, right? That I think a lot of us struggle with at the moment, and
Mm,
I sure as hell do not have an answer to that. I have thesis, I
no,
have ideas, but these, at the rate of change we are seeing, it's so
yeah,
incredibly difficult to make any long term thinking on this, right? I had
yeah,
2 episodes back where we talked about this with one of my friends about those. What's the name? Post labor economics is the
mm,
term for this stuff, right? And yeah,
mm,
it's a fascinating space of like, obviously we have concepts like UBI, universal basic income, and stuff like that around supporting the economy. But to your
mm.
point, I mean, kind of looping back to what you were saying before, it's hard to get young people into what traditionally been blue collar labor, but they are probably more future proof than being a computer software engineer these days, right? In many
Yeah.
ways.
I mean, look at electricians, plumbers, you name
Yeah.
it. I mean, they can charge a serious buck when they come to
Oh yeah,
fix your
just try to get
toilet. Or
anything. Yes, just try to get anything done, like anything in your house or for work. Right? It's, yeah, absolutely. They can command very good day rates. So
mm,
absolutely, there's a shortage, a massive shortage of that. So
yeah,
absolutely, there are there are far more people that probably should be spending cycles on looking into those space because they're harder to replace. Like, it's going to be a lot harder to build a machine to replace a toilet than it's going to be to build a machine that's going to write your backend code.
yeah, exactly.
uh,
Yeah.
or be a lawyer or whatever it is, right? So absolutely. Um,
Mm.
Marcus, this has been very interesting. Any closing thoughts? Any closing words before we wrap up? Things people should be paying attention to. Things you are paying attention to that other people should pay attention to. Anything else you want to
No, I've enjoyed. I hope I haven't rabbited on too much about
add? No, it's
my
been
varied
super interesting.
career. But yeah, I mean, I personally, I'm at the moment very interested in health and the technology underlying that, and edge computing, machine
Mm,
learning, and so on, with the project we have with Invisa. So yeah, I think health is probably one of the areas which I feel all this technology kind of brings together in a way that gives immediate benefit and feedback to the individual and also to society.
100%. I'm a big fan of connected smart devices. He's got a new smart water bottle that just counts how much water I'm drinking. Uh, if you can't measure it, you can't manage it, as the old saying goes, right? And
Correct.
I'm a big fan of that. So absolutely, I'm 100% on the same page. Measure
Yeah.
everything, and then maybe you throw away 90% of the thing you record, but the remaining 10% might be life saving in 10 years.
Yeah.
So
Absolutely. Yeah. Yeah.
so
Particularly with your health.
yeah. Shout out to another Swedish company. Well, not another, but Neco Health is another one that's
Yeah.
very cool in that space. I did their stuff a few months ago, and that's super
Uh-huh.
cool. Give you a
Yeah.
full body scan, and so shout out to Neco for being very good on preventive health. So that's another good one.
Correct. Yeah.
Perfect. Marcus, thanks so much for coming on the show, and have a good one. Thank you so much.
Thanks,
Cheers.
Victor. Take care. Bye.